Monday, February 1st, 2021. And our I Can for Math today says, I can split fraction models to find equivalent fractions. Sometimes people also say they're going to decompose to find smaller unit fractions. Either way, we're going to be finding some equivalent fractions using pictures today. So let's start with some happy counting. All right, let's see if we can count to 10, counting by ones. All right, ready? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We did it! Hooray! All right, that wasn't too hard, was it? Let's count to 6 now instead. Now brace yourself. Just to 6, okay? 1, 2, 3, 4, 5, 6. We did it. Let's count to 6. No. Let's count again, but let's count by sixths this time. So I'm going to say 1/6, 2/6, 3/6, 4/6, 5/6, 6/6. And what is 6/6 equal to? 1 whole. You'd have the whole chocolate bar, wouldn't you? All right, so let's count again. Except this time when we get to 6/6, we're going to say 1 whole instead. All right, so we have 1/6, 2/6, 3/6, 4/6, 5/6, 1 whole, because 6/6 equals 1 whole. Let's try it again, and this time we're not going to say 6/6, and we're not going to say 1 whole. We're going to clap when we get to the 1 whole spot. So we have 0/6, 1/6, 2/6, 3/6, 4/6, 5/6. That was for 6/6. Now we have 7/6, 8/6, 9/6, 10/6, 11/6, 12/6, 12/6. What do you think 12/6 would be equal to? Look, if I had 12/6. Well, if I decomposed it into 6/6 plus 6/6 more, 12/6 would be equal to 2 wholes. So let's count one more time all the way to 12/6, but we're going to clap every time we get to a whole. Okay? Starting at 0/6. Ready? Go. 0/6, 1/6, 2/6, 3/6, 4/6, 5/6, 7/6, 8/6, 9/6, 10/6, 11/6. And I clapped because we got to 12/6, which is equal to 2 groups of 6/6, or 2 wholes. We'll come back to that in a little bit. All right, let's try a practice problem before we get to your application problem, okay? So I do want you to write this one down. Maddox needs 3/4 a cup of milk to bake brownies. Thanks, Maddox. He only has a 1/4 measuring cup. I'm sure you could call Camille to borrow the other ones, but if you only had this 1/4 measuring cup, the question is, how many times would he have to scoop the 1/4 to get 3/4? All right, so Maddox needs 3/4 of a cup of milk to bake these yummy homemade brownies, but he only has a 1/4 measuring cup. The question is, how many times would he have to scoop the 1/4 cup to equal 3/4? Well, let's see. I'm going to draw a picture to show fourths. I know this is 1/4, 1/4, and 1/4, and 1/4. Now, how many of these do I need, or does Maddox need, for his brownies? He needs 3/4. So if he didn't have a measuring cup that just said 3/4, which I bet he does, how many times would he have to scoop his little 1/4 cup to get 3/4? Well, let's see. This would be 1 scoop, 2 scoops, 3 scoops. So he would need 3 scoops of 1/4, and that would equal 3/4. Because 3 times 1/4, if we did it 3 times, if I took 1/4 3 times, that would give me 3/4. All right, it's time for an application problem. So I want you to turn in your book to page 21. This application problem is remarkably similar, but there's one word that is going to try to trick you. So I want you to read the question 2 times before you get started. I'll give you a hint. The word you should look for is the word double. Look for the word double and then press play when you're finished with your application problem. All right, moving on. Let's do a couple of examples to show how we decompose fraction models to find smaller unit fractions. I'm going to start with an example of 1/3. So if I were drawing 1/3 in my chocolate bars, I would draw a chocolate bar or a tape diagram. You know what? For this example, we're going to put our measurements on the top. So this piece is 1/3, and this piece is 1/3, and this piece is 1/3. Now, I'm going to draw another chocolate bar on the bottom. You really could have put it on the inside. Here, we can put them back on the inside if you prefer them there. I guess for this example, it'll be easier. I want to take each piece. Right now, they're all split into thirds. And remember, fractions like to be fair. So whatever you do to one piece, you're going to do to all of the pieces. If this piece is 1/3, and I decide, hey, let's cut the piece in half. That way I can share it with more friends. If I split this piece, then guess what? I need to split that piece and split that piece because fractions like to be fair. Now I'm going to count how many pieces I have here. Well, I have 1, 2, 3, 4, 5. I have 6 pieces. So how big is this piece, this unit fraction? Well, it's 1/6. And how big is the piece next door? 1/6. How big is the piece next door? 1/6. And how big is the piece next door? 1/6 and 1/6 and 1/6. Fractions like to be fair. They're all the same size. So I'm going to get my colored pencil out. And I'm going to color in 1/3 on the top. If I have 1/3 of my chocolate bar, how many sixths would I have to color in to equal 1/3? If I colored in 1/6, is that equal? Is that the same amount? No. If I color in 2/6, is that an equivalent amount? Yes. So we could say that 1/3 is equal to having 2/6. Another way to represent this is I could say 2 times 1/6 equals 2/6. Remember, our denominator stays the same. All right, we're going to come back to this. I know that some of you can already see a pattern here that you might want to talk about. We'll talk about it in just a second. Let's try example number 2. This time, I'm going to start with 1/6, which is what we had up here. So I'm going to make another chocolate bar. Remember, I always try to keep my chocolate bars about the same size because when we compare them, it's much easier to compare pieces that are split similarly. If I need 6 pieces, I'm going to make 5 lines. So 1, 2, 3, 4, 5. Now this gives me 1/6 and 1/6 sixth and 1, sixth and 1, sixth and 1, sixth and 1, sixth. I'm going to draw the same size chocolate bar below it because I want to split these pieces and see what I end up with. So wherever I had a piece, I'm going to split it. Are my pieces getting bigger or smaller? Smaller. I keep splitting my pieces. Look, this piece is tiny. This piece is tiny. Look, because whatever we do to one, we have to do to all the rest. And now I want to count to see how many pieces I have down here. So I like to count by putting a dot. That way, if I can't fit my unit fraction in each piece, I know how many I've counted. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I have 12 pieces. So how big is each piece? 1/12. I could try to fit it in there. I could probably fit a couple of these. Unless your pencil's super sharp, you're gonna have a hard time. I maybe should have made my tape diagram a little bit larger. No big deal, we can zoom in. All right, well, we're trying to compare something to 1/6. So I'm gonna get my colored pencil and I'm gonna color in 1/6. Well, 1/6 would be equal to how many twelfths? How many pieces down here do I need to shade to equal 1/6? Does 1/12 equal 1/6? No. Does 2/12 equal 1/6? Yes. So what we can say is 1/6 equals 2/12. And we proved this using our fraction model on the tape diagram or the chocolate bar. So if 1/6 equals 2/12, what if I decided to change our question right in the middle and said, oh yeah, well, what's 2/6 worth? Well, I'm going to color in 2/6 now. That's this part right here. That's 2/6. How many twelfths would I need to equal 2/6? Would 3/12 be equal? No. Would 4/12 be equal? Yes. So we could say that 2/6 is equivalent to 4/12. And we proved this using our visual model, using our chocolate bar. All right, let's try another one. I'm flipping to the back. Remember, we're paper savers. Trying to save the world one paper at a time. All right, so I'm on the back of my page. This is example number 3. We're going to start with 1/2. Oops, sorry, you couldn't see it. All right, my fraction is 1/2. If I want to draw 1/2 on a chocolate bar, tell me what to draw. Draw my chocolate bar. Split it in half. And this time, look, I'm going to label on top of my chocolate bar this time. This is 1/2 and this is 1/2. How many of these should I color in to show that I have 1/2 of my chocolate bar? Yeah, let's just color one of them. This shows me 1 out of 2 pieces. So right now my unit fraction is 1/2 because everything's being counted in 1/2. But of course, we are going to find an equivalent fraction to 1/2. So what we need to do is we need to split these pieces to make them smaller. So if I split this side, let's remember, fractions like to be fair. Whatever I do to one side, I have to do to the other side. Now let's count on the bottom. Let's see, I have 1, 2, 3. Now I have 4 pieces on the bottom. So how big is each piece? 1/4. 1/4. 1/4. 1/4. This is how you can represent your fractions in the same chocolate bar or the same tape diagram. So here's my question. How many fourths do we need to equal 1/2? So 1/2 was my big piece up here before I split it. This part over here is 1/2 also. But now that I've split it into fourths, how many fourths do I need? Well, we need 1, 2, because those are the two pieces that are colored in. So I could say that 1/2 is equal to 2/4. Now I'm going to change this one up just a little bit. Still doing 1/2. What if I wanted to take my 1/2? Still 1/2. 1/2 on this side, 1/2 on this side. It just shows 1 out of 2. Even gonna still color it in. What if I told you, hey, I want to change my tape diagram. Let's decompose this. Instead of halves, I want you to make it into eighths. So we have to change our fraction. 1/2, I want you to turn it into eighths and tell me how many pieces you would need. Well, right now I only have 2 pieces, but I want to make 8 pieces. So let's split my chocolate bar. Let's see here. I need 7 lines to make 8 pieces. So this is 1, 2, 3, 4, 5, 6, 7. Now let's count how many eighths we need. 1, 2, 3, 4. So this is 1/8, 1/8, 1/8, 1/8. And if I add all those up together, how many do I get? 4/8. This is how we decompose fractions into smaller unit pieces. So we're going to do some practice today from your book, and we're going to work on our Zern afterwards, so please take your time. We are on lesson 4 in your book. You're going to turn to page 23. Let's get started. Please take your time and do a good job. We'll see you tomorrow.